Okay, welcome back. Today we're going to talk about linear functions for my Math 150 class. This is section 3.2. So today we're going to talk about lines, we're going to talk about slope and slope-intercept form. So first of all, ARC. Some of us may have recognized this acronym. This is average rate of change. Now, when we think of this, we think of average rate of change as slope, especially when you're dealing with graphs and lines. Now, what is the formula for this? Well, M equals, okay, I'm going to say rise over run. Now, I want you to think about this for a second. The reason why I misspelled rise is because the top part of this is the y. It's y2 minus y1 over x2 minus x1. Okay, once we establish the ARC, we can talk about slope-intercept form. Now, some of us right off the bat may recognize this being y equals mx plus b. Now, m is our slope. B is our intercept, which is our y. I'm going to put y-intercept y-int. Now, I'm going to give us a few examples of using slope and how to come about it. So when I think of slope, automatically I will put down m equals y2 minus y1 over x2 minus x1. Now, this is just my rule of thumb. I just go ahead over here on my coordinates, and I'm going to do my first one as x1. If that's x1, the next one has to be y1. And then my second coordinate, x2, y2. Remember, x always comes before y. Think of the alphabet. Now what I'm going to do is I'm going to substitute these values in. I'm going to say, I'm going to take my y, I got ahead of myself. My y2 is 2 minus 5 over 16 minus 21. This comes out to be 2 minus 5 is a negative 3. 16 minus 21 is a negative 5. Since I have two negatives that cancel each other out, my answer is 3/5. So at any part of this video on my examples, like I've stressed before, always pause it, work it out, and then come back to mine. Okay? Now, I always like defining them. So I'm going to go ahead and I want to say x1, y1, x2, y2. It doesn't matter which x1. If I could have used x1 as the 11 as well, but I just always choose the first one. Now, what the slope of this is going to be is I'm going to take my y2 value, which is 14, subtract 9. Now, this is where we make a lot of mistakes. We put our 11, but then we automatically put in a minus 7 because that's what it is, but that's not what our formula says. Look at our formula. It's a minus. So you minus, and then since our 7 is negative, just like this. So then I can go ahead and carry out my operations and say 14 minus 9 is 5. Now, 11 minus a negative gives me a plus 7 now. So now that's 11 plus 7, which is 18. Now, on your homework assignment, you're going to be given slope, you're going to be given coordinates, but it's going to ask you to find a missing point. So what I'm going to do is I'm going to go ahead and write my slope formula one more time. And now I'm going to assign my values. X1, Y1, X2, Y2. Now in this case, my slope, my M right here is -2, but now I can start plugging my values. Y2 is what we're trying to find. Y2. But on our coordinate thing, I'm just using, or my coordinates, I'm just using Y. So it's going to be Y minus 5 over 2 minus 6. So now what we continue to do is we're going to work this out. So I still have my -2, Y minus 5, but now I can, at the bottom, I can say, I can do 2 minus 6, which is a -4. Now I need to isolate that Y. So what I want to do is I want to multiply by -4 to cancel that -4 out. But if you multiply by 1, you have to multiply by the other side. So that's -4 times a -2 now, which gives me a -8 equals Y minus 5. And I'm almost finished. I don't know why I have that should not be a -8. That should be a +8. -4 times -2 is a +8. Let me erase that for a second. And then all I'm going to do is add 5 to both sides. So Y equals 13. And here's how you know you're correct. If you put 13 in for Y right here, this Y right here, 13 minus 5 is an 8. We already know what 2 minus 6 is a -4. So 8 divided by -4 gives you that -2. That's how you know you've went back and you can check your answer, see if you got it correct. Now they can give you something like if they could give you f of 3 equals 8, f of 4 equals 9. Now in this case, this is understanding functions. Remember, it's always f of x, and it equals y. So I can go ahead and assign x1, y1, x2, y2. And I could go ahead and put my slope formula. So it's y2, which is 9 minus 8 over 4 minus 3, which is 1 over 1. So in this case, this is an easier answer. Comes out to be 1. Now, your answers of these could be positive, they can be negative, they can be 0, they can even be fractions. So just be aware of that. Okay, now it's time to talk about, we talked about slope, now we're talking about some intercepts. So slope-intercept form. Slope-intercept form, we need to solve for y. So what I'm going to do real quick is I'm going to go ahead and recopy this because I'm going to do some work. So what I'm going to do is I'm going to box in, or you can circle the y and whatever is in front of the y. In this case, it's a -4 or a -4. That means I'm protecting this negative 4y. I need to get rid of this 5x by subtracting it on both sides. Now, I'm going to put that negative 5x in front. That 20 is positive. I'm going to put plus 20. We cannot combine 20 and negative 5x because they do not have the same like terms. And then I want to divide, because it's negative 4 times y, you do the opposite. Now watch this, you have to divide everything. So my answer, so those cancel, so negative 5 over negative 4. So y equals 5/4 x, and then 20 divided by negative 4 gives you a negative 5. This is my slope-intercept form. It's y equals mx plus b format. The m can be a fraction, it can be positive or negative. The b in this case, since the confusion part is it's plus b, but it can be a minus b. So what is the slope? Well, the slope, remember, is mx. So it's in front of the x, which is 5/4. The y-intercept is just negative 5, or for coordinates purposes, it's always 0 and then whatever the y-intercept is. Now, to find the x-intercept. Okay, there's a couple ways to show us how to do this. What I want you to do is I want to go ahead and I want to show you what I call it's the cover-up method. Some of us may have heard me use this before, but this is a method to find the x and y intercepts. But the problem is you have to have the x and the y on one side and the number on the other. So let's take a look at this. The cover-up method means this. Now, I'm fortunate I can come back and undo what I'm going to do right here. Okay, so if I want to find the x-intercept, that means I don't want to have the y or anything to it. So what's left is 5x equals 20. Remember that, 5x equals 20. I'm going to put it over here on the right side, or left side, I'm sorry. 5x equals 20. Then go ahead and solve. I divide them by 5. So you have x equals 4. Or, as far as the coordinate is concerned, the x-intercept is 4, and then it's always 0 for your y value. Okay? Now, to find your y-intercepts, now we already did this, but this is to say we didn't put it in, we didn't have it in y-intercept form, slope-intercept form. Take a look at this. You get rid of the 5x, it's a cover-up, so we erase it. What's left? Negative 4y equals 20. Divide by negative 4. And you get y equals negative 5. The same as what we have up here. Now what I want you to do on this next example is the exact same setup. Push pause and go ahead and work this out. So remember, the slope-intercept form, we're trying to define y, so I'm going to protect it. By doing that, I want to get rid of the 16x, move it on the other side by subtracting it. You do the opposite. So you have 4y equals negative 16x plus 32, because 32 is positive. then I want to divide by 4. So 4 goes into negative 16. So these cancel. So 4 goes into negative 6, negative 4, and then x. And then 4 goes into 32 plus 8. So from this, my slope is always in front of the x. That's my m. So in this case, m equals negative 4. My y-intercept is at 8, or it's 0, 8. And x-intercept, remembers, you have to check this off. I've got my x and y on both sides, and I got a number on the other. So what I want to do is I want to do what I just explained earlier, is the cover-up method. So to find my x-intercepts, there goes my y. So what's left is 16x equals 32. Divide by 16. X equals 2, or it's 2, 0. Depends on what they ask you. They can ask you for the point, or they can ask you for the coordinate. Or the line. The line equation is x equals 2. The coordinate answer would be 2, 0. Okay. To find the y-intercept, cover up the 16x. What's left? 4y equals 32. 4y equals 32. Divide by 4. Y equals 8, which is the same as what we have right here. So that's another way to check your answers as well. So now we'll end with this lesson with 2 word problems. And I try to use real life situations instead of using just what the usually books get. Okay, now, normally what I do is I go through a big explanation about my experience with games. So all I'm going to say is that my up-to-date version is a Nintendo Wii for my cousins, nieces, nephews, and even my kids. So I'm learning a lot about these Xbox One and the updated versions. For me personally, I always love the arcade games like Pac-Man and Donkey Kong. But in this case, if I ask the class how many owns or games, a lot of us are probably going to raise their hand, which is fine. So anyway, so let's just say Dalton buys an Xbox One game for $300, and each game cost him $50. So let's just say that this is a flat out value. There's no tax or anything. I'm trying to make this as simple as I can. So I could ask you, okay, write a formula. Well, unless the problem specifically says what you need to use, I'm going to just say cost per game, because the value depends on how many games we purchase. Okay? So now our slope, or our average rate of change, meaning how much is it per game? It's $50. And how much is the Xbox? $300. So that means that this is a way Dalton can keep up of how much it's going to cost him to buy a system and however many games. So part B, it's asking him, okay, how much money is it? How much will it cost him for 7 games? Well, the cost value for 7 games, so it's going to be 7. The G we know is 7, so I'm going to say 50 times 7 plus 300. So 50 plus 7 is 350 plus 300. So he's going to have $650 worth of games in the system. Okay. Now, what about if he did have $1,000? Let's just say he got $1,000 for Christmas or birthday or whatever the case is. And he wants to know, okay, if he buys, he has to buy the Xbox system, how many games can he actually purchase as well? Well, in this case, what I'm going to do is I'm going to say, okay, it's $1,000, it's 50 per game, and the Xbox is going to cost me right off the bat $300. So then what I want to do is I want to just solve it just like an equation, and I'm going to subtract 300 on both sides. That should have been 1,000. I don't know what happened right there, but it should be 1,000. So I'm going to subtract 300 on both sides, and you get 700 equals 50G. Next, what I want to do is I'm going to divide by that 50. So the total amount of games that he could buy would be 14. Now that's a lot of games, I think, but hopefully he can pick and he can pick and choose and have fun with 14 games. Okay, my last example. Now, all those that are familiar from where we're from, Court Day, it's a big, huge festival, and what people do is they go there, they sell food, arts, just antiques, everything at Court Day. So let's just say we have Melissa in our class that rents a booth at Court Day for $300 for the whole festival and sells L8, which is a soda, for $1 a can. So what would be a good formula? Well, the money it's going to cost, I'm going to use money this time. I'm going to say money is going to depend on what? How many cans Melissa sells. Now, in this case, I'm going to put, you don't normally have to do this, but I'm going to put a 1C for knowing that it's $1 per can. Now, if it was $2 a can or whatever, you'd put a 2 there. But now, $300. Now, is the $300, do we add 300 or subtract 300? Well, since she rents it, she owes. So that means she's going to be in the hole of the $300. Now, the ARC, what is the slope? Well, it's just that dollar per can. What is the break-even point? That means how many cans does she need to sell to offset that $300? So what I'm going to do is I'm going to go ahead and I'm going to put 0 in for the money, because that means we broke even. I'm going to say 1C minus 300. Some of us could do this in our head, but I'm just showing you how to set this up because not all of them are this straightforward. So then I'm going to add 300 to both sides. So it's 300 equals C. So she has to sell 300 cans to break even. Okay. Let me scroll down here. Let's just say, what is the initial value? Well, the initial value means, what did she start off doing? She started off owing negative 300. And finally, if she makes a total of $1,500, how many cans does she sell? Well, it's easy for us to look at this equation and say, well, or this problem and say, well, if $1 a can and she makes $1,500, does that mean she sells 1,500 cans? Remember, she still owes. So what I'm going to do is I'm going to put in for the formula $1,500 she made. I'm going to say 1C, still, this is our original formula, 1C minus 300. So now I'm going to add 300 to both sides. So that means, how many cans does she sell? She sells 1,800. Think about this for a second. 1,800 times 1 is $1,800, but then she had to make a deposit of 300, so she came out with, that's where she came out with $1,500. Okay, now for my class, this is going to be homework number 5 on WebAssign. Okay, thank you for listening, and be looking up for the next video, which is my video 3.2, or it's my more on linear equations. Thank you for listening.